Okay, here on example number 4, we are modeling translations of trigonometric functions. So they give us this example where a person is jumping rope. The height of the rope is oscillating between a maximum of 108 and a minimum of 0. So we're not going negative, we're just bottoming out at 0, which means there must have been some vertical shift pushing the whole graph up. Hits the ground 2 times per second. Write a function that represents the height of the rope, y, at time x seconds, if the rope begins at a height of 0 inches at time equals 0. Okay, so they say that they're going to use cosine. We could use sine or cosine, but I'll just go with cosine to match kind of what the book's doing. If we go over to Desmos, so first of all, just kind of trying to get the details in that we want. If we said 108 cosine of x, that would make us go from 108 down to, now my axes are a little funky here for what we're trying to display, but it would go from 108, positive 108, down to negative 108, right? We don't want that. We want it to go from 108 to 0, which means that we are going to need to have our whole, we're going to have the amplitude be 54, first of all, and we're going to have to raise up by 54. So effectively what this does is it keeps that maximum of 108 on there, but it gives us a minimum of 0. And we'll see that better when we kind of compress the whole thing inwards. And let's do that compression. So based off of what was stated in there, they say they want to hit the ground 2 times per second. 2 times per second. So we want our frequency to be 2, right? Frequency is 2 times per second. Now our period is always 1 over the frequency. Okay, so keeping in mind, if you're going to hit it, if you're going to hit the ground 2 times per second, that means you should be going up and back down, doing a full rotation every half a second, right? So the period, which is going to be 1 over the frequency, is going to be 1 over 2. Now, the relationship between the period and that b value was that typically we say that our period is always equal to 360 degrees, if we're working in degrees, over our b value. Okay, so 1/2 needs to equal 360 over b. Okay, well, if I solve for that, I would get b equals 720 degrees, or b equals 720. So our b value should be 720. Let's see how that affects our graph. We definitely know we need to do some big time compression. So we're expecting we're going to have some large number out front here. 720 do for us. It does indeed scrunch up our slinky pretty good here. And what we now have is a function that's going from 108 down to 0. Okay, that's what we wanted. It is hitting the ground, well, let's say it differently. It is doing 2 cycles every second. That is exactly what we wanted. Now, the only thing that we didn't want it to start up here at the top. We wanted it to start at 0, 0. So we're going to have to move, basically we'd move this point over to the left by 0.25. So I'm going to say plus 0.25 so that we go to the left. And once I've done that, I think we are in good shape. We now have a function that starts at 0, goes up to 108, comes back down to 0, so that's 1 full cycle. It does 2 full cycles, hits the ground twice every second. Okay, so our final equation for that given scenario would be 54 times the cosine of 720 x plus 0.25 plus 54. Okay, so a lot of things going on in there. I would typically recommend saving the horizontal shift for last, because like I kind of alluded to in a previous video, the horizontal shift and the horizontal compression will kind of mess with each other. So if you were to, for example, have done the horizontal shift first, let's say we didn't have this number right, and we just wanted to shift it so that we were starting at 0, 0. Well, I think I would have had to subtract, what would I have to subtract? 3. I'm not sure exactly what the number is, but I would not have been subtracting 0.25, right? I would have been subtracting 0.25 times 720, I think. I think I'd be subtracting 180, but yeah, there we go. I'd be subtracting 180 to get it down there. So you can do that, but then by the time that you do your compression, it kind of throws things off. So if I put that 720 back in the front again, well, now I'm not at that 0, 0. So I would recommend doing your horizontal compression before you try to do that horizontal translation, because if you wait for that one last, you can get the frequency right, the period right, and then just kind of look down here and say, okay, how much am I off by? I want this point over here to the left by 0.25, so I'll just say plus 0.25. Not required that you go in that order, and probably most recommended that you just kind of play around with this on your own until you find what you yourself are most comfortable with. But that would be how we'd get through example number 4.